2022 series of workshop on Filecoin. My name is Charles Freeborn. You can find me on Twitter at Charlie Coates. I happen to lead the Orbit Community Program for Africa for the Filecoin, IPFS, Lipi to every other project that's on the protocol labs. And so today I'm going to be giving you guys an overview of IPFS and Filecoin. And our agenda is going to take the approach of, first and foremost, we'll take a look at what IPFS is, what Filecoin is, and then we'll look at the core concepts around Filecoin, and then possibilities around Web3. Right, so we'll get started with IPFS. So IPFS at the most fundamental level is actually the entire around, first and foremost, it is distributed. That is, there is no central server. There is no central server. It is resilient and offline first, and then built to also upgrade the web. So let me start first by talking about what we mean by when we say the interplanetary being distributed and no reliance on a central server. So the web, primarily as we know it, is powered by the HTTP protocol, right? So for HTTP, basically you have a server, like a central server where users make requests to. Requests could be from a user agent like your web browser or your mobile web browser. Basically, user agents, web browser, whether you're accessing the web from a mobile device or a laptop computer or a desktop, you're actually making a request to a server in a central location. Probably these servers could be in places like a data center. So what happens majorly is like there seem to be like, so if we're accessing the web, basically it means through a central server, it means that there is a single point of failure, right? So if there's a challenge with the server that you're requesting an information from, let's say example.com, you're visiting a website and you're targeting a particular server and there is a challenge, let's say power surge or a power outage in the central location where the server is actually based, you may not be able to access the contents. Does it make sense? So that's what it means by when you have a central server. So most times what organizations do to try to mitigate these issues of having a single point of failure is probably have to set up data centers in different regions or locations. So if, let's say, we have a data center in, let's say, Warri, for example, and you're trying to access information or the server in this particular location and there's a challenge in that region, we could push the request to the closest or the next available data center. But in all of this, there is still like a central control, a central server actually determining or controlling the information on the websites that we get access to. On the other hand, we have distributed system where that doesn't rely on a central server. So it works basically like peer to peer, right? So we could liken it to say that a user could actually be not just being the receiver or requesting information, but you could actually still save this information. So we could basically set up what we call nodes, like you have different pairs. So I could be, let me use the term we're using, let's say something around BitTorrent, for example, to explain. How many of you have done something around BitTorrent, trying to use BitTorrent? So in BitTorrent, this thing we call seeding, where the availability of the data, for example, is based on how many pairs are actually serving or seeding the data at that particular point in time, right? So no reliance. So basically, when we say a central is distributed and no central server. That means we're not reliant on a single or a central data. So because of that, even if, let me use the word server for example, there's a server for example serving content, and that server is cut off the network, you could still get access to that website data of information from the other nodes that are actually serving them. Makes sense? And then we now looked at, for interplanetary, we talked about being resilient and offline first. So by being resilient, it means that, borrowing from what we said about, right, you don't need internet access. So with IPFS, you're able to still get access to data and information even if you don't have access to the internet. Then another key point about IPFS is the fact that it was actually set up to upgrade the web. And in all of these things, how does IPFS do this, or how does IPFS actually get to work behind the scene? So we look at content addressing. So the web currently as we know it is majorly location based. By location based, it means that if you're requesting a website, if you're making a request to, let's say, a particular website for example, you are actually targeting a location. Makes sense? You're targeting a location. Let's say example.com, you're actually requesting for content on, let's say, example.com from a particular location. So what that means is, if I'm making requests for content based on the location, right, the challenge is, if I'm making requests, let's say this is a stationary, this is where this stuff is located, and you already know that there's a unique address tied to this location. If I move this content to this place and the address that you have is always pointing to this location, when this thing is moved, when this item is moved from this point to a different address, what happens? You are able to get access to it, right? So IPFS, so this is basically how the web is like. So most requests that we make on the web goes through, we're targeting is location based addressing. For IPFS, we use what we call content addressing. By content addressing, we mean that information, files, data, whatever it is that you're actually requesting for is served to you based on the content you are requesting for, not the location. Do you get? So what that means is this: if I have a file, for example, saved on, I will upload a file, or I'm saving a file, for example. This file could be the content of this file can be distributed around across different nodes and different pairs, right? So if I make a request for a particular file, for example, or data or information, whichever node that I'm connected to at that particular point can actually save me that content, can save me the information, because these nodes or pairs have that same content. So okay, it's like okay, I'm requesting for XYZ content, so the feedback, what is delivered back to you, is based on the content that you are requesting for, and not on what's the word, and not on the location, right? So it doesn't matter. So if the content that we're requesting, for example, is in a different location or a different geographical location, but the node or pairs that are close to you have that same content, it can be delivered to you. So that means content delivery is actually faster, right? So and content addressing uses CID, content identifier, likened to, so every content that we save on the Web3, every content that we save, for example, has, or uploads, that has a unique identifier, the content identifier, which works through cryptographic hash. Probably get back to that. So content directory has the macro tags, macro directed acyclic graphs, that's DAGs, the graphs or data structures where each node is content addressed. So the key takeaway, the key distinction is that for HTTP, it is location based identifier. For IPFS, we are using content addressing, or content addressing, which you can get through the content identifier CID. And maybe I didn't mention this, but I'll take it back a bit, that just like you have HTTP as a protocol powering the web, or Web 2 currently, IPFS is also a protocol powering Web 3, right? So you can come of there are other works that are being done behind the scenes to actually allow for support for IPFS across different these different browsers. So you could literally access the web. Let me use the word server. I can set up my device or my system to be like a node or a server that you can use to actually save out information or content. He can actually do the same, you can do the same. So we could have what we call a swamp, like a network or a connection of nodes or pairs that are actually serving content. So the pair is the unit of pair-to-pair system. Every pair uses a cryptographic key pair similar to HTTP for the purpose of one, identity, a unique name in the network, and channel security, as encryption. So currently the unique name, a unique identifier, I don't know if you can see this clearly, the unique identifier for pairs in IPFS, a mixture of different letters or characters that currently doesn't look like is human readable, but they're actually unique. And one of the uniqueness about this is the fact that we use what we call cryptographic hash or cryptographic key. So a cryptographic hash, let me explain what cryptographic hash or cryptographic key or hash is. HASH. So when you upload data or information on the Web3 space, for example, let's say on the blockchain, a hash is generated which is unique to the content that you are uploading or generating. So with this hash, we can actually do what we call verification or proof of work or proof of stake, right? Such that if an individual has that same hash for verifiability across the network or the protocol, so if there is a change in that content or moderation, a new cryptographic hash or key is generated. So if you try to do some form of verifiability or whatever or what have you, is going to what? It will fail. Do you understand? Alright. Then how do we get to use IPFS? So firstly, remember that IPFS is a protocol for the decentralized web. Getting to use IPFS, we could use IPFS by running peer-to-peer nodes and why. Okay, so using IPFS in the wide, who runs IPFS nodes and why. So who are the individuals that actually use IPFS and who runs these peer-to-peer nodes? First and foremost, I think I mentioned this earlier, you can actually set up your own nodes on your device. You can run your own nodes. Number one, you can run your own nodes. Number two, you can hope that your contents become popular enough that other nodes will probably pin it. So the first one is akin to, like, let me say, call this like something like self-hosting, right? So you are running your own node on your own device, but other pairs who are actually connected to the network can actually see or get access to, can actually get to see the content that you are sharing. So what we're saying, if it is valuable enough, you can hope that the content becomes popular and valuable enough for other people to actually get to share your content or pin it on their own node, right? So that now helps in what we call what, easy dissemination or spreading of information. Recall what I asked about seeding, for example. If the content isn't popular, for example, or is not being seeded, if you're looking at it from the lens of the bits, looking at it from the lens of torrent, for example, you may not be able to get access to the file, right? So if the content is popular enough, people can, other nodes can actually pin it, like make it to be some form of being permanent. Number three, you can run your own network of nodes and an infrastructure team to manage it. Then number four, you can pay a pinning service to pin your content on their nodes. Examples of this pinning service could be Pinata, Tempra, Ifura, and all and more. So what about alternatives that are centralized and reliable? That's where Filecoin comes in. So with IPFS, for example, as a protocol for a decentralized web or decentralized network, we can set up nodes and probably preserve information and data. And then there is Filecoin, complementary, built on top of IPFS. So Filecoin is a storage system, a decentralized storage system built for the Web3 from the ground up. So what it basically means is that to be able to preserve or store information on the Web3, we have Filecoin. So Filecoin is a storage system designed for Web3 from the ground up. Filecoin is compatible with IPFS and Web3. It is verifiable via cryptographic proofs. Is a massive decentralized network. So let me start with Filecoin being compatible with IPFS and Web3. We use IPFS as a building block to share all the benefits of content addressing and CIDs. So with IPFS, we could integrate with Web3 networks like Near, Chainlink, Hedera, and more. The compatibility with Filecoin's compatibility with IPFS and the Web3 space in general is that not only is Filecoin a protocol, it is also a storage system for the D-Web. And one of the things that we're excited about for Filecoin is the fact that we're able to, through Filecoin, preserve humanity's information over a long period of time. So with Filecoin, for example, you could Filecoin has some form of crypto economic incentives plugged into it, which I'll come back shortly. I'll share more light on that. But basically, Filecoin is not a it is not centralized, so it is decentralized, like everybody contributing some form of storage space to the Filecoin network to be able to give everyone on the web an opportunity to actually preserve their data and information over a long period of time. So how does this work in Filecoin? Or one of the goals behind Filecoin is this: let's say you have this device and you have an unused storage capacity on this device. Let's say 1 terabyte of unused data, unused storage space on this system. We are saying you can set up to be like, if you can set up to become a Filecoin storage provider, right? Plugging into our network to be a Filecoin storage provider, and being able to, first and foremost, so you are not providing, you are combining to the total number of hard disk or storage space that we now have access to across the globe. Does it make sense? Or do I need to explain that again? What we're saying, okay, let me try to explain again. What I'm saying is this: so a Filecoin, there is what we call, so first and foremost, there's what we call the Filecoin storage provider. The Filecoin storage provider is, you have unused storage capacity, let's say 1 terabyte of unused storage capacity. So instead of just having this space, let's say this hard disk capacity, not being utilized or not being used, we are saying become a storage provider on the Filecoin decentralized network, and then individuals, organizations, or people that want to store their information on the long term can actually now store their information on your hard disk. Do you understand? So the question is, why would I want to give you, or why should an individual supply his or hard disk capacity to preserve somebody else's data on the Filecoin network, storage network? That's where the crypto economic incentive comes in, right? So besides being the fact that Filecoin is a storage network for the D-Web, Filecoin is also a cryptocurrency, right? So storage providers are incentivized or paid in the Filecoin, in our cryptocurrency, the Filecoin coin, crypto, which you could exchange for BTC, USDT, and probably even fiat, right? So do you understand now? So that is one. So we talked about being verifiable. So how do you get to know that the data that is being stored on the Filecoin network is actually being preserved or still being kept? That's where verifiability comes in. Okay, I think this is a bit clear. So verifiability comes in. So we could verify it through cryptographic proof. So you can prove that. How can you prove that you are really storing my data and keeping your promises? How can I enforce that in? How can I enforce this in a decentralized network? Through cryptographic proof, right? So one of the things about the blockchain web, decentralized web, is the fact that we are able to verify stuffs like publicly, right? So you provide your storage space, you are helping to preserve humanity's information over a long period of time, and then you are getting some form of incentive in native crypto coin, native cryptocurrency. And then there is the aspect of retriever. So it's a win-win situation. So the one who is, so if the individual, for example, organization or group of individuals needs to now get their file back, they also have to pay the storage provider with file to be able to retrieve their information. And it's beautiful because it's now helps us to actually get to preserve information for a very, very long time. I think I once talked about how there were some contents that I used to create some couple of years ago that I'm unable to get access to because these contents got off the internet. So with Filecoin we can preserve information for a very, very long time, and then it's a massive decentralized network, right? Governed by consensus instead of a single corporation. So it is not controlled by. Yes, there is. So the files are actually not. Yes, so these files are shared among the across the nodes on the network, right? So that is why we started by talking about no reliance on a central server. And I think that is why you also have to pay to be able to retrieve the file, because the file is distributed in bits across different nodes. Yes, different. Yes. All right. So the core concepts around Filecoin. Number one, verifiable storage. So the core concepts, verifiable storage on Filecoin. So number one, you or your app will make a deal with a provider to store your data, right? So Filecoin prepares your data by transforming it into a directed acyclic graph. It uses the same process as IPFS, so the resulting CIDs are compatible. So recall we talked about the content identifiers, which is unique to that data, right? So that's the same concept that Filecoin uses, just like we have in IPFS. Then number two, storage providers generate an initial proof of replication, which is what you just asked about. Initial proof of replication. That's part of the storage deal that they publish to the Filecoin blockchain. So so you don't just say, okay, yes, I provided 1 terabyte of hard disk space, so I'm actually storing. You have to actually provide an initial proof of replication that you're actually storing and preserving this data or information over a period of time. Then number three, over time, providers have to keep proving. So I think Lawrence mentioned this yesterday about how you have to keep proving over time that you still have. Over time, providers have to keep proving that they still have subsets of your data, creating proofs of space-time. They are paid incrementally for keeping up the storage deal. So what this means is you're actually accumulating. So you accumulate Filecoin. For proving that you're actually still preserving it, you get your incentives just keep saying getting higher. Then number four, You get your data by making retrieval deals. So I've already mentioned all this. You can also check the chain for proof that is being stored and stored correctly at any time. So just in case you're even worried, you can actually still check the blockchain to be sure that your data is still being stored and stored over time. Alright, so core concepts. IPFS getting to meet Filecoin. So why IPFS is for fast, flexible. Filecoin is both a protocol and a network, right? So most users will take advantage of the ecosystem of libraries, tools, and services to build great apps. So this data, you can see the projector there, is the current usage and storage information data around the current usage around the storage provider distribution on the Filecoin network. Let's move to the next slide. So what can you, in all of this, what can you build with Filecoin? So with Filecoin you can actually build decentralized apps. That's what we call dApps, right? I'm not afraid of dApps. Decentralized apps. You can build web apps. You can build DeFi apps or protocols, or basically stuff across the blockchain, basically on Web3. You can build with on Filecoin, and then Web3 all the way down. So what you can actually build with Filecoin, Web3 all the way down. So for the D-Web, currently I have a browser on my machine, for example, and I can actually access the web through the IPFS protocol. So all the way down you have like a hierarchy is showing front end. The front end loads from IPFS. So okay, maybe subsequent workshops or meetups, I'm going to do a demonstration around getting to use IPFS on the Brave browser. So we could load our front end with IPFS, just the way you can actually load your front end with HTTP. So maybe you could one key take is probably just get to install Brave browser on your device and try to look at IPFS. I think you go to settings and set up an IPFS there. You can log in with a D-Web wallet, then storage provider helper. So content can be stored on IPFS or Filecoin. I don't want to use the word database, but maybe that's something that you could relate with. So okay, maybe just for today's talk, I just say that. So basically what we're saying is we could use, this isn't too clear. So we could use IPFS or Filecoin to store content, and then we can actually still access the front end through IPFS. So going to quickly run through a couple of tools that you could actually use in storing data. There's Flick IPFS. Add your build settings, deploy your size to IPFS, backup to Filecoin. That's interesting. So usage includes GitHub Actions, CLI, GraphQL API. I think this is beyond the scope of this talk currently. So let's quickly just look at storage helpers for dApps. You have storing and retrieving data. We strongly recommend choosing a storage helper. Recall what we said about storage helper. Let me go back some. So storing and retrieving data, we recommend that you choose a storage helper. It simplifies deal making. Then you can also store to both IPFS and Filecoin with a single core. IPFS for fast, flexible retrieval, Filecoin for persistence and verifiability. Still on storing data. So the FlickSpace Diamond, you could, I think I will share this later with you, so you could get an idea of maybe go through the docs for display FlickSpace Diamond. And then there is also, so apart from Flick, there is also Estuary, ESTUARY. So there's docs.estuary.tech. Estuary is a general Filecoin and IPFS storage for seamless deal making and verification. Works through how it works. So data is immediately uploaded to a hosted Estuary node, automatically stores with 6 providers around the world. Its usage includes HTTP API, coil, and web interface. So just quickly running through getting to store data. So there is also NFT.storage for NFT, designed for NFT developers who want free decentralized storage. So NFT is currently like a big word. That's non-fungible tokens. Talk about that in a subsequent meetup or workshop. So how does getting to store data on NFT, how does it work? So you upload your data and get back an IPFS hash of the content. Recall what I told you about when you upload data, there is a CID, a unique content identifier, a hash that is generated that can be stored on chain. So you upload your data and get back an IPFS hash of the content, a CID that can be used in on-chain NFT data as a provider. So you have storage. So interestingly, for storage and retrieval is free. You get properly formatted metadata back, and you can fetch it back through IPFS. You also get to backup. So how it works, you back up to Filecoin, right? Usage includes, so you could use a JS library, JavaScript library, client library, HTTP API. Is also conjured as a remote pinning service. So there's also PowerGate. The PowerGate is designed for developers who want powerful ways to connect and extend the P2P, IPFS, and Filecoin. It bridges to near and is coming soon to ETH, that's Ethereum, Polygon, and others. It works with Docker container. How it works: Docker container wrapped around an IPFS node and Filecoin node. Stage, store, and retrieve data. Default configs for miner or provider selection. So for usage, you have the JavaScript clients and Go clients, gRPC API and CLI, and then last but not the least, so in all of this, we're looking at getting to build a Web3 enabled architecture with decentralized possibilities at every layer. So basically, currently for front end, for example, okay, I think this is a bit. So currently for front end, for example, you have on the Web2, you have web apps and data solutions. For Web3, currently we are looking at NFTs, dApps, and more. DeFi, smart contracts, whatever. So the architecture basically follows. So the front end could be, let's look at Web3 for example. You have NFT, dApps, and others or more, and the logic, standard application logic or smart contracts, right? And then you have storage helpers. Storage helpers are some of those technologies we already talked about. NFT.storage, Estuary, Flick, and then we have the Filecoin and IPFS. The same for Filecoin. You have docs.filecoin.io, right? So getting started, and then we also have the proto.school, a unique platform, interactive for, so it's an interactive training platform or online school for everything around Web3, IPFS, Filecoin. And then there is the NFT.school, NFT specific tutorials and demo. And then we also have our hackathons. I talked about our hackathons. So maybe you want to participate in our hackathons. So you have the hackathons.filecoin.io, where you have dozens of virtual events for learning, mentorship, building, and competition. So happy to entertain questions at this time. All right, let's hear. Okay. This is quite interesting. So, yes. So, getting to answer this, so there's a project that we're working on right now. That's we have a space. We have a project, a space-based project. So, I'm going to redirect you to a site called Are We Interplanetary Yet? Just a second. So used in space, right? The first confirmation to use IPFS, well, actually, IPFS-Tiny is a cubic picosatellite made by the fine folks at the Liberal Space Foundation to low Earth orbit in 2022. So there is work is actually ongoing to actually get to. Is it streaming now? How do I say this now? Get to take IPFS or into space, right? So you should follow this. I think we also have a GitHub repo for this, and I'm sure over time, even if you're in desert or anywhere you find yourself in the world, you will be able to still access your file. So does that make sense? All right, what's the next question? Yes. You said you have a question. right? Yes, it's yes, valid point is possible, right? And yes, the answer is yes, and this is the reason why we are asking everybody to be a part of, to come on board and be a part of this, so we can all actually get to have a voice or a stake in this, right? So if you leave it to the, if you have the assumption that, valid assumption that the big players are, we're trying to fight with platforms like DAOs where everybody comes together and become like stakeholders in getting to set up an organization, so there is no central authority or like a chairman or chief executive. So basically how DAOs work in getting to mitigate all of this is the fact that everybody contributes in, let's say, cryptocurrency or some kind of funding to actually get to set up the organization, and then whatever decision or whatever it is that will make, the final decisions that we make is going to be based on general agreement or a consensus before we move on to the next phase or take on any projects. Any other? Okay. Yes. So we're working as, Filecoin is actually a blockchain. So first and foremost, it has, so there is the Filecoin ecosystem, right? So yes, yes, and yes, right? So first and foremost, Filecoin is a blockchain on its own with the ecosystem built around it. So the other ecosystems or toolings built around Filecoin, Stride.tech, NFT.storage, these are the tools that make up and whatever that make up the Filecoin ecosystem. And then we also have opportunities for collaborations with these other technologies or tools that you mentioned. Yes, so that's also kind of I think it's not supposed to be on this talk, but it's something that also now leads to the Filecoin. So we have the Filecoin Foundation, for example, that encourages individuals, and which is one of the things we're also doing to actually build on top of our blockchain, on top of our technology, and then maybe we can encourage some form of grants, right? So so our ecosystem supports individuals, organizations like you, and so come and build on top of the Filecoin ecosystem, right? Build your apps or your dApps on top of the Filecoin ecosystem. Show us what it is you're building, maybe on Filecoin or even IPFS, and we could offer some form of grants or to you. Any other question? Okay. Okay, so when we say offline first, or how you actually get to save data, uh, let me see, caching. Do you understand the concept of caching, for example? Okay, caching, CACHE, right? So if so let me try to explain from web 2 something that you probably familiar with. If you've visited a website before, right, it is stored. There's a cookie maybe on your browser that stores the sites that you have visited previously. Okay, so somebody who's visiting a website for the first time will have a longer request time, a longer time to have the content delivered to his or device than the one who has visited the site before. Do you understand? Okay, so that is what caching is. So when we talk about offline first, we're saying you can still access data if you don't have access to the internet, like your access to the information. So offline first, or being reliant, offline first basically means that you should not be stopped from getting access to the information that you're supposed to get access to just because you do not have access to the internet. Still doesn't make sense the way I'm looking at you. Okay, let me try to break it down to you. For example, okay, I want to try to use something that you can relate with. The kind of internet speed, for example, that we have in sub-Saharan Africa, Nigeria specifically, is not as high as what you have in, let's say, in the Western world, right? So most times tech organizations would build apps or their platform to be able to serve you content with even with a low internet bandwidth, even if it drops down to like 2G, right? So we have to, if it drops down to like 2G or 3G, right? So if you are a traditional web developer, the normal web developer, so this is not web3 now, we'll come back there. If you're a normal web developer, when you're building, one of the major concepts that you are actually encouraged to learn as a web developer is being able to take what we call mobile first approach, one, and then offline first. By mobile first, we are saying that you have to understand that most people access websites currently through their mobile devices. So if you're a web developer or a web designer, you should first build for mobile users. That's what we call mobile first, right? Then you now move to what we call offline first. So what happens if somebody is trying to access your website and the person's internet is unstable or not let's not call networks, not fast, not stable, or not reliable, right? You should still be able to build your app, or your website should still be able to deliver your content. Maybe serve up the minimum content that needs to be served first, at least just to encourage the person visiting our website that okay, there is hope first before the main content is served. So that is mobile first and offline first. So by mobile first, so you now look at things like the website has to be responsive, right? So these are the approach. So when we now talk about being able to access data offline, it is based off the fact that these nodes, these different computers that have been set up as nodes or as spans already have the data on their already have the data stored as though it is on a local space, on a local space, local it is on a local space. Do you get? That is why we are saying that you are actually providing physical hard disk space. Does it make sense to you now? So you're actually providing physical hard disk space which is plugged to the internet. The reason is we want to be able to verify that you did not clear off or probably empty the data on that your physical space, and you are still claiming that you are actually still providing the data. So we will just use verifiability to probably do some form of proof of work or verifiability to actually show that the data that you are storing on your machine locally is still persistent, is still there. So long as we're already connected on the node, just like the way you have like LAN, like a local area network, you will still be able to get access to the data offline. Okay, please. Oh, I think I have water behind it. 2 more. All right. Yes. Okay.